So in this video, we're going to go over graphing transformations of the parent functions. And so we're taking f of x and we're mapping it to a times f of x minus h plus k. And if you remember, you will learn eventually when there's a coefficient in front of x. We're not worried about that right now. And so I break it down into three different steps to graph these functions. So the first is to identify the parent function, and with that you should know the shape and you should know some of the key points that are on the parent function. If your a value is a fraction, you want to think strategically about the key points on the parent function because you want to make the math a little bit easier for yourself, and you'll see an example of that. Once you know what the parent function is, you're going to have to identify the a, h, and k values that are going to transform the parent function. And so, they're going to be in the equation. The a will be in front, k is usually the constant, and then the h is attached to the x in some way. And then we're going to perform the transformation on the key points. So you're going to see when I do some examples that I make a table. And so if you remember, the x coordinate is only affected by what's inside the function notation, the x minus h. And so we're going to add h to the x value. And then to find the new y value, where it maps to, is we're going to do a times y and then add our k value. For our functions that have vertical or horizontal asymptotes, the vertical asymptotes will shift with h. So if every x value shifted 4 units to the right, then your vertical asymptote will also shift 4 units to the right. Similarly, the horizontal asymptote, if you shifted 4 units up, the horizontal asymptote will also shift 4 units up. So I'm just going to go through some examples of this. You're going to have to practice this. It's the only way you'll get better at graphing these transformations. All right, so let's start with example 1. We're going to graph the function y equals negative 3/2 times the absolute value of x minus 4 plus 5. And so the first thing you need to do is identify what type of function this is. And so this is going to be an absolute value function. And so the parent function for that was y equals the absolute value of x. Okay. Step 2 is identify your a, h, and k. So a is negative 3/2. H is positive 4. And k is positive 5. So step 3 is to form the transformation. We're going to map our xy's we're going to go to x plus h and then a times y plus k. And so the way I do this is I make a table. And so the left side here, this is for my parent function. And so if you remember our parent function, we had 0, 0 is where the vertex would be. And we knew that 1, 1 was on it, and we knew negative 1, positive 1 was on it. We know that this looks like a V. Now, in the previous slide, I talked about thinking strategically. And since I have a fraction here, I'm actually going to use x values that will give me an output of an even number, so I can get rid of that fraction. So I'm actually going to say negative 2, 2 and positive 2, 2. I'm not going to worry about 1 and negative 1, 1. Negative 2, 2 is still on this function, so is 2, 2. It's going to make the math a little bit easier as we map it. So we're going to map this. I'll change the color of my pen. Let's go blue. And again, we're going to map this to a new function, which will be x plus 4, and then a times y plus k. So I'm going to do negative 2 plus 4, right? That's this point here. Well, that's going to give me the point positive 2. And then when I plug in 2 for y here, that's going to give me negative 3 halves times 2 plus 5. Negative 3 halves of 2 is negative 3 plus 5 gives me positive 2. And so I know I have a point at 2, positive 2. When I plug in 0, I get 0 plus 4. It's going to give me a new x value of 4. And then when I plug in 0 for y, we would have negative 3 halves times 0 plus 5. And so I'm at negative 3 halves times 0, which is 0, plus 5 gives me the point 4, 5. And note, this is my vertex, right? This was the vertex of my parent function. Put a v there. So I know this is my vertex for my transformed function. The last one, I'm going to take the point 2, 2 and plug it in. So I would have 2 plus 4 gives me a new x value of 6. And then when I do negative 3 halves times 2, that gives me negative 3 plus 5, I get positive 2 again. And so I'm at the point 6, 2. And so this should give me enough points to know the shape, which is the V. And I can draw the best I can through those points. And so that gives me the function y equals negative 3 halves times the absolute value of x minus 4 plus 5. Example 2, we have the function y equals 2 times the square root of x plus 2 minus 3. And so, 1, I know the parent function is y equals the square root of x. 2, I know my a value is 2, my h value is negative 2, and my k value is negative 3. And so my h and my k are going to tell me my start point for my square root function. If you remember, it's going to look something like this. And so I know I'm going to start at the point negative 2, negative 3. That's my start point. 3, I'm going to make my table. For my parent function, and so some of the key points were 0, 0, 1, 1, 4, 2. And so we're going to map this to our new function, which will be x plus 2, x minus 2. And then we'll have 2 times y minus 3. And so when I plug in 0, 0 minus 2 gives me negative 2. And then when I plug in 0 for y, I get minus 3. And so that's where we start. We start at negative 2, negative 3. When I plug in a 1, I have 1 minus 2 is negative 1. And then when I plug in a 1 for y, I get 2 times 1 minus 3, which is also negative 1. And so we have a point at negative 1, negative 1. And if I plug in 4, 2, if I plug in 4 for x, 4 minus 2 is 2. When I plug in a 2, 2 times 2 minus 3 gives me a positive 1. And so at the point 2, 1, I have another value. I'm going to do one more. If I plug in 9 for my parent function, I will get a 3 out. And so when I do 9 minus 2, I get 7. When I do 2 times 3 minus 3, 6 minus 3 is 3. And so at 7, I'm at 3. And so I have enough points here that I can get an idea of what my graph looks like. I'm going to draw a smooth curve that goes through all 4 of those points. Draw my arrow, signify that it goes on forever in that direction. And so that's the transformation of the square root of x to y equals 2 times the square root of x plus 2 minus 3. In our next example, we're going to go over the function y equals negative 1/2 quantity x plus 2 cubed plus 1. And so this function is a cubic. So this is our parent function, y equals x cubed. Identify your a, your h, and your k value. So my a value is negative 1/2. Your h value is negative 2. And your k value is positive 1. Step 3, for my parent function, I had points that were key, would be points like negative 1, negative 1, 0, 0, 1, 1, and I'll add one more, 2, 8. And so we're going to perform the transformation on our x's and our y's to see what our new graph would look like. So I'm going to make a new table. X plus negative 2, and then I'm going to have negative 1/2 times my y value plus 1. So when I do negative 1, negative 1, well, negative 1 plus negative 2 gives me negative 3, and then 1/2 times negative 1 plus 1 will give me 1/2. And so at negative 3 on the x, I go up half to find my y value. When I plug in 0, 0 plus negative 2 gives me negative 2. And 1/2 of 0 is 0 plus 1 is 1. So at negative 2, positive 1, disregard that 1 point there. So at negative 2, positive 1, we have a point. At 1, 1, if I do 1 plus negative 2, that's going to give me negative 1. And when I plug in a 1, I get 1/2 times 1 plus 1 will give me 3/2, or 1 and 1/2. So at negative 1, I'm at 1/2, 1.5. If I plug in a 2, 2 plus negative 2 is 0, and 1/2 of 8 plus 1, well, that will give me 5, so at 0, I'm at 5. Let's add one more point. If I add negative 2, my output would be negative 8 for my parent function. So negative 2 plus negative 2 is negative 4. 1/2 of negative 8 plus 1 will give me negative 3. And so at negative 4, negative 3, I have another point. So I added that point just so I have a better idea of what the shape's going to look like. And so a cubic increases and decreases pretty quickly. So we're going to go through that point. It's going to start curving. We hit our point of inflection at negative 2, positive 1. And then I'm going to turn and go up. And so that's a rough sketch of what the graph would look like. So that is a cubic transformation. So again, notice the point of inflection for our parent function would be at 0, 0. It shifts to the left 2, and then up 1. So that's a cubic function.